today we start with our 8th chapter, motion. Motion, something moving. There's a famous saying, there is nothing like absolute rest. Everything is moving. You can see the bird flying. We are moving in our house. The earth is continuously rotating and revolving. So we are on the earth, so we are also moving. Now, study of object at rest or motion, we call it as mechanics. Now, mechanics are divided into two main branches. One is dynamic, the other one is kinematics. Dynamic means what causes motion. It is the cause of motion. Study of cause of motion, we call it as dynamic. For example, electrodynamics. Kinematics is the study of motion with respect to time. Now, when we are talking about electrodynamic, that means motion due to electric field. So, in this chapter, we are going to talk about motion term. Now, we see the classification of motion. Motion can be classified in 1 dimension, 2 dimension, 3 dimension. When we talk with respect to the frame of reference of the axis, motion in 1 dimension along a straight line. It's a motion along a straight line. Motion is also known as rectilinear or linear motion. So, motion in 1 dimension is also known as rectilinear or linear motion. Moving train in a railway platform, railway track. You can see it's moving in 1 direction. So that is a linear motion. Now motion in 2 dimension. Well, we need 2 coordinates, maybe x or y. So 2 coordinates specify the position of the object. So motion in 2 dimension is an object that moves in a plane. You consider this blackboard or a carom board. 2 plane directions are there, length and breadth, whatever it is. So that's a frame and you are standing outside that frame. So that is 2 dimension. Carom is moving in that 2 direction. Motion in 3 dimension. That is everything, all the 3 coordinates specify the position of object and changes the object moves in a space. For example, the object moving in a space. Bird, it's in motion, space. We are there. We can see that thing. So, gas molecule in a cube, that is also a motion in 3 dimensions. Now our actual topic. What is motion? We are going to talk about motion in 1 dimension, that is linear motion. So what is motion? An object is said to be in motion if it changes its position with passage of time. As the time changes, the position also changes. The 5 parameters that we are going to study, that is distance, displacement, speed, velocity, acceleration. All these 5 are interconnected. The first one, distance. Suppose I am starting from my home to school without any stop, straight. That is the distance. But if I start from my home, goes to some Naranpura, then again come back to Ashram Road, then again move towards Thaltej and then to school. So I'm taking so much zigzag path. But when you're talking about distance covered by me, in the second one where I'm stopping going 3-4 places, that is more. So the sum of all that distance is covered, path covered, we call it as distance. So Distance, the actual length of the path described by the particle. That means from my home to Naranpura, then again Naranpura to Ashram Road, again Ashram Road to Thaltej, Thaltej to school. All this distance path I have to add up, that gives me distance. Dimension of distance is only length. So it's M0, L1, T0. SI unit of distance is meter. So when we are talking about distance, only we have to see about the magnitude, the kilometers that I have covered. So distance is the actual length of the path described by the particle. It is a scalar quantity. Scalar means where only magnitude is there. There is no direction. We have another quantity known as vector, that is having magnitude and direction. So distance word means you have to know what is the magnitude, how much path you have covered within how much time. That is only magnitude is calculated. Now if I take 3 kilometers from my home to a point B, from there I take 7 kilometers to point C, and D, the school, is 8 kilometers. So 5 plus 7 plus 8. Total distance covered is 20. So magnitude is the value of distance. So distance is sum of the path covered. Now displacement. It is the minimum distance between the initial and final position of a particle. That is the shortest distance between 2 points, both magnitude and direction here included. So that means if I start from A to B, B to C, C to D, but the shortest distance will be A to D. So here the two initial and final point gives the minimum distance between initial and final position of a particle, gives the displacement. It is a scalar quantity. Scalar means which is having both magnitude and direction. It is same path, length of the path, but the shortest path. So unit of displacement is also meter. So dimension is M0, L1, T0. The next topic is origin, the point from where the object moves. Now the example I give, I start from my home. So my home is the origin point, and the final, that is the initial point, and the final point is the school. So that is the final position. So when you're talking about displacement, the sign convention take place. If you are moving towards your right direction, it is positive, and if you are moving towards the left direction, it is negative. Now the main importance between distance and displacement is distance is always greater or equal to displacement, because displacement is the shortest part. So what is distance is always greater or equal to displacement. Now we see the difference between distance and displacement. First point of distance, total length of path covered by a body. Second point, it is a scalar quantity. Third point, for a closed path, distance travelled is non-zero. Fourth, distance will never decrease. It will always increase. Fifth point, it always positive. Displacement. The shortest distance between the initial and final position is called Displacement. It is a vector quantity. For a closed path, displacement is always 0. You take us, if you're moving in a circle, for example, the initial point, you start and come back to that original initial point. So, what is the initial and the final points are same? So displacement, there is no change in position. So displacement is 0. Displacement may decrease. And fifth point, it may be positive, it may be negative, or it can be 0.
Now we see about the uniform motion. If an object covers equal distance in equal interval of time, however small the time interval may be, then the motion of the object is said to be uniform motion. For example, suppose a bus moved 10 kilometers in the first 15 minutes and 10 kilometers in second 15 minutes, then 10 kilometers in third 15 minutes and so on. Then one can say that the bus is in uniform motion because the time taken by the bus to travel the 10 kilometers are same, that is 15 minutes. Now non-uniform motion. If an object covers unequal distance in equal interval of time, it is said to be non-uniform motion. Most of the motions seen in our daily life are non-uniform motion. For example, the car in the traffic jam. If we drop a ball from a roof of a building, we will note that the ball covers 4.9 meter in the first, second 14.7 meters, and so on. So the time goes on changing. Time interval is not same. That is, the ball covers increasing larger distance in a successive seconds as it falls down. Thus, the motion of a freely falling body is a non-uniform motion. The other examples of non-uniform motion are a stone dropped from the top of a building, a ball thrown vertically upward, the motion of a train as it leaves the station, the motion of a bus as it approaches the bus stop, the motion of a ball rolling down on an inclined plane. Now let's see about speed. Speed is defined as the distance traveled by a body per unit time. Thus, speed equals to distance traveled upon time taken. If we consider speed by small v, distance traveled by small s, and time by small t, then v equals to s upon t. The SI unit of speed is meter per second. Whenever the distance covered by the body is expressed in meter and time in second. A smaller unit of speed is centimeter per second. A larger unit of speed is kilometer per hour. Speed is a scalar quantity because it has only magnitude and no direction. The speed of a body tells us how fast or how slow the body is moving, but it does not give the direction of the motion. The next parameter is velocity. It is a physical quantity that gives both the speed and direction of the motion of the body. Velocity of a body is defined as the displacement produced per unit time. It is also defined as the speed of the body in a given direction. Velocity equals to displacement upon time. If small s is the distance traveled by a body in a given direction and small t is the time taken to travel that distance, then the velocity is given by v equals to s upon t. The SI unit of velocity is also meter per second. Velocity is a vector quantity because its description requires both magnitude and direction. When can we say that the body is said to have uniform velocity and variable velocity? Uniform velocity. If a body covers equal distance in equal interval of time, however small this interval may be in a given direction, its velocity is said to be uniform velocity. So in uniform velocity, a body moves with uniform speed in a given direction. For example, light travels with a uniform velocity 3 into 10 raised to 8 meter per second through vacuum. Variable velocity. When a body travels unequal distance in equal interval of time, or its direction changes or both changes, its velocity is said to be variable velocity. For example, a bus turning at a junction has variable velocity. Now, average velocity. When the velocity of the body changes at a non-uniform rate, its average velocity is defined as the net displacement covered divided by the total time taken. So, average velocity equals to total displacement upon total time taken. When the velocity of the body changes at uniform rate, the average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity equals to initial velocity plus final velocity upon 2. If u is the initial velocity and small v is the final velocity, then average velocity is given by VAV equals to u plus v upon 2. Now, acceleration. Acceleration in a non-uniform motion, the velocity of the body changes with time. It has different velocity at different instant of time and at different point of its path. In such a situation, we defined a physical quantity called acceleration, which is a measure of the change in the velocity of a body per unit time. Acceleration is defined as the rate of change of velocity. If the velocity of the body changes from small u to small v in time t, then acceleration is equals to change in velocity upon time taken. That is, small u means initial velocity and small v means final velocity. So, acceleration equals to final velocity minus initial velocity upon time taken. So, acceleration is denoted by small a equals to v minus u upon t. As acceleration has both magnitude and direction, it is a vector quantity. The SI unit of acceleration is meter per second square. When the velocity of the body increases with time, its acceleration is positive, like that of a bus when it leaves the bus stop. Retardation, it is the negative of acceleration. That is, when a velocity of the body decreases, its acceleration is negative. So, negative acceleration, we call it as retardation or deceleration. When a stone is thrown upward, it is under retardation. Similarly, when a bus approaches a bus stop, its motion gets retarded. Now, when you can say that the body is in uniform acceleration or non-uniform या variable acceleration. Uniform acceleration. If an object travels in a straight line and its velocity changes by equal amount in equal interval of time, however small the interval may be, the object is said to be in uniform motion, uniform acceleration. For example, a body falling freely to the ground has uniform acceleration of 9.8 meter per second square, and its velocity increases by 9.8 meter per second after every 1 second. Non-uniform acceleration. If the velocity of the object changes by unequal amount in equal interval of time, the object is said to be non-uniform acceleration or variable acceleration. For example, if the speed of a car traveling along a straight road increases by unequal amount, then the car is moving with non-uniform acceleration. Let us see some example of uniformly accelerated motion. An object moving with uniform speed along a circular path has uniform acceleration because it forms a tangent at each point. Because the velocity of that object changes continuously due to the change in its direction at each point. The motion of a ball rolling down an inclined plane is uniformly accelerated